information gained from Vanguard 1 has enabled us to determine the true shape of our Earth. It is slightly pear-shaped. It is slightly pear-shaped. This is a report on the United States space explorations of 1958. 1958 has seen notable progress in the space effort of the United States. 5 U.S. satellites have gone into orbit. 2 space probes were launched. The first in October traveled about 71,300 miles. And the second in December ascended 63,580 miles above the Earth. Here is the story of these historic contributions to science. On January 31st, the United States Army was ready to launch a Jupiter-C missile with a satellite payload. 80 days before, clearance had been given to proceed with the launch. The Army selected the Jupiter-C because of its proven reliability. The California Institute of Technology's Jet Propulsion Laboratory, now under contract to NASA, designed and manufactured the advanced stages and the payload. The payload transmitters would have an expected broadcast life of 2 weeks for the 60 milliwatt transmitter and 2 months for the one putting out 10 milliwatts. The payload measured 80 inches by 6 inches and weighed 30 8/10 pounds. Each component in the high-speed assembly was spin tested. It was thought that centrifugal force might distort the structure of the solid propellant within the high-speed rocket motor. It, too, was subjected to spin testing.
Attention all personnel. Please clear the launching area for radio frequency interference tests. Please clear the launching area.
This is Ray.
Command transmitter on.
Telemeter on.
Frequency measures 2.5 low.
Calibrator on.
Dovap on.
Keep radar off. This is Project Command. The time is now X minus 33 minutes. Authorized personnel may resume work on pad. Resume work on pad. Hold for final transmission test. This is Project Command. My command mark, the time will be X minus 15 minutes. Mark, X minus 15 minutes. All personnel clear the launching area. All personnel clear the launching area. The signal is 2.5 kc low. Channel 1 is now reset. Channel 2 is reset. Channel 3 is reset. The figure for Channel 1 is 430. Channel 4 is reset. Channel 5. This is Project Command. The time is now X minus 13 minutes. Start vibration record. Begin cluster run-up.
The cluster is starting its spin. Transmission of all payload electronics components is now being monitored.
This is Project Command. The time is now X minus 4 minutes.
After the firing signal is given, it will take almost 16 seconds for the vehicle to take off. Pressurization will be started at X plus 3 seconds. At X plus 14 seconds, ignition will begin. Thrust buildup will continue until liftoff at about X plus 16 seconds.
launching was a success, and the first United States satellite was named Explorer 1. Explorer 1 made the most important discovery of the International Geophysical Year: the existence of a great belt of radiation, identified by Dr. James A. Van Allen, head of the State University of Iowa Physics Department. On March 17th, St. Patrick's Day, Dr. John P. Hagen of the Naval Research Laboratory announced that Vanguard was poised and ready to launch from the Atlantic Missile Range, Cape Canaveral. Vanguard 1, an Earth satellite, was placed into orbit with a perigee of 409 miles as its closest approach to the Earth and an apogee of 2,453 miles from the Earth. It is expected to stay in orbit for hundreds of years. Its solar batteries will power transmitters, which will give information to generations of scientists of the world community. Information gained from Vanguard 1 has enabled us to determine the true shape of our Earth. It is slightly pear-shaped. Explorer 3, launched 9 days after Vanguard 1, achieved orbit and yielded valuable data on the radiation belt discovered by Explorer 1. It recorded micrometeor impacts, which gave information about the density of cosmic dust, and it recorded internal and external temperatures of the satellite. The next United States success in space came with the launching into orbit of Explorer 4 on July 26, 1958. As a scientific experiment, it confirmed and expanded the data on radiation and temperatures discovered by satellites Explorer 1 and 3. On March 27th, the Advanced Research Project Agency directed the Space Technology Laboratories to proceed with a series of lunar probes. The payload was designed so that its electrical system would have maximum possible life. The experiments, aside from an electric scanner, would measure radiation, magnetic fields of Earth and Moon, density of micrometeoric matter, and internal temperatures. These probes would use hardware developed for the Air Force Ballistic Missile Division as advanced re-entry vehicles. The first stage, Thor, develops a sea level thrust of 150,000 pounds. 2 vernier engines rated at 1,000 pounds of thrust provide roll control and final adjustment of burnout velocity. The second stage was a modified Vanguard second stage with a gimbaled, regeneratively cooled thrust chamber. It had roll control and a separation system for detachment from the first and third stages. The third stage used an Allegheny Ballistics Laboratory solid propellant motor, which was designed for use as an advanced high-performance third stage for Vanguard. An explosive bolt separated the third stage from the payload and fourth stage. The Able 1 vernier and spin motors were also developed for the Vanguard program. The fourth stage rocket was a solid-fuel Thiokol Corporation motor. The trajectory for Able 1 required a high degree of precision in launching time. A period of about 20 minutes of each of 4 successive days constituted the permissible launch time. Because of the required timing accuracy, several scheduled holds were incorporated into the countdown. The countdown included second stage propellant loading, electrical systems checks, and the ordnance tasks, first stage engine checks and fueling, tower removal, regulator setting, and liquid oxygen fueling, count, and finally launch. At 73 6/10 seconds, a turbo pump failed, and the liquid oxygen pump stopped. The experiment was an apparent failure, but science learns from failure as well as success. On October 10th at 3:42 a.m. Eastern Standard Time, the second experiment in this series, an Air Force Thor-Able 1 space probe under the management of the National Aeronautics and Space Administration, achieved a near-perfect takeoff, just 13 seconds later than scheduled time. Good performance was obtained from both the first and second stages. However, the second stage velocity was 190 feet per second less than expected, and at shutdown, the second stage was lofted 3 degrees too high. The third stage velocity was 500 feet per second less than desired. The Millstone Radar Station at Massachusetts Institute of Technology acquired and tracked the second stage. The Manchester Station at the Jodrell Bank Radio Telescope Installation, Manchester University, tracked the payload Pioneer 1 for several hours on each day of the 2 days' flight. The first day, the Hawaii Station tracked from the time Pioneer 1 was acquired until it sank below the horizon. On the second day, Hawaii tracked the payload as it approached the Earth, then lost it as it plunged toward the sea in the southeastern Pacific. Because of the deficiencies in the speed of the second and third stages, all Vernier rockets were fired in an attempt to make up this velocity deficit. The added impulse was not sufficient, and escape velocity was not achieved. The National Aeronautics and Space Administration estimated that the fourth stage and payload reached an altitude of 70,717 statute miles. An attempt was scheduled on December 6th to place a United States space probe beyond the moon. Jupiter was selected as boost vehicle for this Juno 2 rocket, which was to launch Pioneer 3. At the Army Ballistic Missile Agency, Huntsville, Alabama, the first stage was modified for this mission and test run. On the West Coast, in Pasadena, California, at NASA's Jet Propulsion Laboratory, the second, third, and fourth stages were assembled. The payload cone undergoing vibration testing was 23 inches long and 10 inches at maximum diameter. Several days before scheduled launch time, the first stage was brought to the launching pad. The morning before launch, the payload was hoisted, positioned in the vehicle, and given final checkout. A few hours before launch, the fueling operation began. On December 6th, Juno 2 stood ready on the launching pad. It weighed 121,000 pounds at liftoff. After the burnout of the first stage, the booster motor separated from the guidance compartment and nose section. Almost simultaneously, the nose section was detached by an explosive charge and moved out of the way by a small rocket motor. Meanwhile, jets of the guidance system were activated to place the high-speed stages and the payload in proper firing attitude of direction. A brief period of coasting followed. Now, with the rocket in effect aimed at its target, the spin-stabilized high-speed stages commenced their firing sequence. With the firing of the last stage rocket, the probe has now achieved escape velocity. After a long period of coasting, about 10 hours, the burned-out fourth stage is separated from the probe payload, and a de-spinning device consisting of weights attached to wires is activated to stop the spinning motion of the probe. The probe payload will now coast on into space. Pioneer 3 rose to an altitude of 63,580 statute miles. During 1958, a large segment of the nation's scientists, engineers, and production experts were drawn together and given direction. Against this background, the country carried out a series of space experiments that yielded valuable data to the world's store of scientific knowledge. There were a number of failures during the year, and the United States promptly announced them. The first and most spectacular of these was Vanguard at the end of 1957. There were other Vanguard failures. All achieved takeoff, but trouble occurred either in the second or third stages. Explorers 2 and 5, Beacon, and Pioneer 2 were also considered unsuccessful experiments. A beginning has been made of which we may well be proud. We are, however, only just over the threshold. Much research, reevaluation, and work lies ahead for us. The United States is aware of the magnitude of the challenge and aware that it must be fully met.